In this lesson, I'm going to talk about gas combustion efficiency. We need to know how to calculate BTU input before we go any further. BTU input is measured by clocking the gas meter. Time the revolutions of the dial for 1 minute and then multiply that number of revolutions by 60. The result is cubic feet per hour. Multiply the input by the efficiency percent to find the output. You can have different firing rates as well in a gas furnace. It means the input is not what it should be. The wrong firing rate can be caused by incorrect orifice sizing or incorrect gas pressures. First, check the gas pressure. Use either the U-tube or another type of manometer. Normal gas pressure will be 3.5 inches water column for natural gas and 11 inches water column for propane. If the gas pressure is correct or it cannot be corrected, fix an overfired situation. The orifice size must be reduced. Fixed orifices are sized by specific gravity of gas, manifold pressures, altitude, and cubic feet per hour. Find the correct orifice for the input. Find the input rate from the manufacturer. Divide this number by the orifices to find the BTU per hour per orifice. You can use a correction chart for higher altitudes if necessary. Combustion efficiency is measured by measuring the products of combustion and the flue temperature. The percentage of oxygen and carbon monoxide that should be present in the flue temperature is known. Measuring the products of combustion can be done electronically or mechanically. An analyzer that is a fluid which will trap temporarily oxygen and carbon monoxide. The percentage of these chemicals in the fluid will change the level of liquid in the fluid pipe. Comparing these byproducts and temperatures on a sliding scale will give you the efficiency. The temperature rise over the heat exchanger must also be correct for the furnace. The tag on the furnace will give the correct temperature across the heat exchanger. Incorrect temperature rise is a sign of system problems. Airflow in duct systems may be incorrect, there might be efficiency problems, and the firing rate may be too low or too high. In order to get your temperature rise, measure the supply and return temperature after 10 minutes of runtime. Subtract these two numbers to find the temperature rise. Take your supply temperature far enough away to prevent the radiant heat from the heat exchanger from affecting your readings. The CFM of the furnace can be found using the temperature rise and the combustion efficiency. You take your CFM equals BTU divided by 1.08 times temperature rise. An example of this, if my temperature difference is 65 degrees, my BTUs per hour is 80,000. My CFM equals 80,000 divided by 1.8 times 65, which is 1139.6 RPM, or CFM. If the temperature rise is too high or too low, make sure the CFMs meet the manufacturer's recommendations or use a rule of thumb, 10 CFM per 1000 BTU.